Hi, in this webcast we're going to have a little whistle-stop tour of multivariate analysis of variance, or MANOVA. And basically you use a MANOVA when you want to look at the difference between groups of entities, but you've measured several outcome variables. So you've not just measured one outcome variable, you've maybe measured 2, 3, 4, 5, 700, maybe you're feeling adventurous. And you want to compare these different groups of entities, but you've got loads of outcome variables, so you can't do stuff like ANOVA t-tests or whatever. So you use this thing called a MANOVA. And essentially what a MANOVA does is it creates, out of your outcome variables, it creates a kind of a linear composite. So it sort of mashes them all together into this kind of one linear component, a bit like a factor analysis. And then what it does is it compares the groups on that linear component that it's created. So it's quite a good way to kind of, if you've got a lot of outcome variables, condense down the information and then compare groups. So we're going to have a look at how to do this on SPSS. We're going to use the example from my textbook. And basically that example was looking at different psychological treatments for obsessive compulsive disorder. Now, obsessive compulsive disorder is characterized, it's characterized by many things, but in terms of the example, it's characterized by having intrusive thoughts. So these are kind of unpleasant, repellent thoughts that kind of pop into your head and make you feel very distressed. And also compulsive actions which you engage in to neutralize those thoughts. So for example, you might have a thought about killing someone, which is unpleasant, and then you have some ritual or some action like tapping the floor 35 times, which neutralizes that thought for you and makes you feel calm again. So we can have two outcome variables. If you want to have a look at the effect that a treatment has on OCD, we could have an outcome variable that relates to the actions or the compulsions that someone engages in, and also an outcome that relates to the number of intrusive thoughts they have. So this is our basic example. We've got two outcomes, actions and thoughts, and we had different groups of people who underwent different treatments. So the first treatment was known as cognitive behavioural therapy, or CBT, in which a clinician will try to address the anxious cognitions that a person has, but also will engage in kind of behavioural experiments and behavioural tasks to challenge these beliefs, or to challenge the thoughts that make someone engage in the obsessive actions. We also had a group who just did behaviour therapy. So the idea behind this would just be that you kind of expose the person to the thoughts that they find unpleasant, and they kind of habituate to them. So there's not really anything dealing with the sort of the beliefs or the cognitions. It's purely a sort of behavioural measure. So getting people to engage in activities that they think are going to make them anxious, to show them that it doesn't make them anxious. And of course we need a control. So we had no treatment, very professional, having a drink in the middle of a webcast. We had no treatment control who basically were left to their own devices. So we've got three groups, CBT, BT, and no treatment control. And we've got two outcomes, actions and thoughts. Now if you have a look at how the data are arranged in the SPSS data editor, you can get the file off the book's website. You can see over here we've basically got a coding variable which tells us which group a case belonged to, and if we toggle between the labels and the values, you can see we've coded them with numbers. So CBT is 1, BT is 2, no treatment is 3, and we've given those value labels to help us identify which group is which. So case 1 is in the CBT group, and after the treatment engaged in 5 actions and had 14 intrusive thoughts. So what we're interested in is whether these groups differ across the number of actions and thoughts that someone has after they've had the treatment. So hopefully if you looked at some of the other videos, you're familiar with how to put data in. So this is just the format that they're in. Each row is a case, and we've got a grouping variable and our two outcomes as different columns. So how do we run the MANOVA? Well, we go to the Analyze menu, and MANOVA is simply a general linear model, as most things are. So we go to that menu, and then within that menu, we go to the Multivariate option. And that brings us up a dialog box, which is pretty straightforward. And basically, you can see there's an option to select dependent variables. So these are your outcomes, basically. So in our case, we've got actions and thoughts. If you hit the Shift key, you can select both of them at the same time. Press the arrow key, or you can drag them across. So we've got our outcomes, our actions and thoughts, and our grouping variable that's the variable that basically we want to compare the groups on our outcome variables. So our grouping variable is telling us which kind of groups to compare. So we can just drag that into the fixed factors box. Now, if you're feeling really, really crazy, you can also incorporate covariates into a MANOVA to make it a MANOVA. And if you did that, you would put any covariates you have in that box there. However, we're keeping things pretty simple. So in terms of options, there's a few things that you can do, really. So what options might be important? Well, we could ask some contrast. So this will be some tests to help us determine which groups differ from which. So if you click on contrast, by default, there will be no contrast set up for our grouping variable. However, we can choose some using this drop-down box here. Now, it might make sense, because we've got a control group here, no treatment control, to do a simple contrast. And remember that our no treatment control was the one that we coded with the highest value. So we coded it as a 3. So it's kind of it's the last category. So CBT was the first category, BT the second category, no treatment was the third category. So if we set up a simple contrast and use the last category as the reference category, what that will do is compare each group to the no treatment, which is kind of what we want, because we want to know whether the therapies work relative to our no treatment control. So we can set up a simple contrast, ask it to use the last category, and click on change. We'll now get a simple contrast. In terms of other things, you can ask for plots. The plots are pretty rubbish. Post-hoc tests, not particularly useful. Options can be useful. So, for example, we could get some means for the different groups on the outcome variables, which might be useful for interpretation. Ask for some homogeneity tests, might be useful, might not be useful. You'll also notice this bootstrap button here, and that's because you can technically do a bootstrap. However, what the bootstrap will do on a MANOVA is it will basically bootstrap the descriptive statistics, so you'll get bootstrap estimates of means and confidence intervals and stuff like that. And post-hoc tests too. What it doesn't do is bootstrap the actual MANOVA. So in a sense, it's not really that useful. So click on OK to run the analysis, and what we should get is a bunch of output appearing in the output window, which is, again, relatively straightforward. So to begin with, we're just told what our 3 groups are, how they were coded in the data editor, and that there were 10 participants in each group. That's all well and good. You can, if you like, have a look at this boxes test of equality of covariance matrices, because in theory, a MANOVA assumes that basically the variances within the outcome variables and the covariances between them are roughly the same across the 3 groups, and boxes test tests for this. However, it's a notoriously squiffy test, so you can decide whether you want to look at that or not. What we're mainly interested in are these multivariate tests here. Now notice there's 4 of them, because as if life wasn't confusing enough, there are 4 different test statistics that you can use: Pillai's trace, Wilks' lambda, Hotterling's trace, and Roy's largest parsnip. And basically, well, you can see, because I rigged the example to do this, they give you slightly different answers. So if you're going to be all kind of p equals 0.05 about how you interpret effects as significant or not, what you can see is if you use Pillai's trace, you get a significant effect of group. Using Wilks lambda, it's just about significant too. With Hoteling's trace, it's not, because it's just over that threshold of 0.05, and with Roy's largest beetroot, it's kind of below again. So we kind of got a bit of conflicting evidence, but really this just kind of shows the pointlessness of using a criterion like 0.05, because, you know, it's a bit silly. All of these are sort of showing you the same effect. It's just some of them happen to be just below this arbitrary threshold and some of them just over this arbitrary threshold. So you might want to conclude that there's, I mean, Pillai's trace is generally a good one to use, other things being equal. So you might conclude, well, because Pillai's trace is significant, we've got a significant difference between the groups. Now the question is, what does this actually mean? Now, like I said, what's going on in a MANOVA is it's constructing a linear composite of the outcome variables. So what this is saying is that the groups differ on that linear composite, right? So that's kind of quite important, because it's not saying that the groups necessarily differ on actions. It's not saying that the groups necessarily differ on thoughts. It's that the groups differ on a composite of those two. So what this essentially tells us is that the groups are different, but we don't know where those differences lie. Now, one way to follow this up, which a lot of people do, but it's not, in my view, a particularly good way, is to then look at individual f-tests or individual ANOVAs on each of the outcome variables. So you can see in this table here, we've got another effective group, but it's been broken down by number of obsessive-related behaviours, number of obsession-related thoughts. So we've got two ANOVAs effectively being done here, one of them on actions, one of them on thoughts. And we can interpret this in the usual way. So we've got an F statistic, and that F statistic has a significance value attached to it. And you can see in both cases here, for obsession-related behaviours, we get a p-value above 0.05, which normally you'd interpret as non-significant. And for obsession-related thoughts, you get a p-value above 0.05, so you'd also say that was non-significant. So we've got a paradox here, in that on the one hand, our overall MANOVA, our multivariate test statistic, is saying, well, there are differences between the groups, happy days, have a tea party, but then when you break them down into looking at the differences for actions and thoughts separately, what you get is two non-significant results. Now that's a bit bonkers, isn't it, really? But it just goes to show you that what the MANOVA's testing is, it's testing differences using a composite of actions and thoughts. So you can have a difference on that composite without necessarily getting differences on the variables that make up that composite when you look at them individually. Which is why, in the book, I suggest following up a MANOVA with a discriminant function analysis, because that's actually a bit more in keeping with the ethos of what your multivariate test is doing. However, that's a whole nother story. Because we asked for some contrast, we'll also get this output here. And essentially what this tells us is, it does a comparison. I mean, it's exactly the same as doing ANOVAs again. So, you know, in a way, it's kind of like, why did you bother doing the MANOVA if you're just going to do a bunch of ANOVAs afterwards? But the contrast, we get level 1 versus level 3. And because of the way we coded the variables, that will be comparing CBT against no treatment control. And you can see it treats behaviours and thoughts again as separate variables, so not like a composite like the MANOVA does. So what we can look at here again is significance values and the confidence intervals. So if the confidence intervals cross 0, if they include 0 within them, then basically that means the effect in the population could be 0. So it's non-significant effect. So looking first of all at our CBT versus our no treatment control, we get non-significant effect of on behaviours and a confidence interval that includes 0. So the population effect is likely to be 0 too, or could be 0. And also for obsession-related thoughts, we get a p-value 0.104. It's above that threshold of 0.05, so again it's non-significant. we got a confidence interval that includes 0. Having a look now at level 2 versus level 3, so this will be comparing behaviour therapy to the no treatment control. We get a significant effect on behaviours, on obsession-related behaviours, because this significance value is less than 0.05, and the confidence interval does not include 0. So both the upper and lower limit are negative numbers, so there's no 0 included there, which again sort of suggests a significant effect. And for a number of obsession-related thoughts, we get a very non-significant difference between, again, behaviour therapy and no treatment. And a confidence interval that includes 0. So that's your basic introduction to MANOVA on SPSS. Obviously the book chapter goes into using discriminant function analysis, and we'll talk about this output a lot more, but that should hopefully get you started.